Okay, so this was done for a request on a customer. He bought 8 panels and he's got, I'm not sure what inverter he has, but he had to parallel them. So we are looking at that. But before that, we have to go and have a look what is his VOC and what is his IMP. So it's the volt open current and also the short circuit current. That is what you're going to look at. So this is 50.88 and 14.39. You can also look at the back of your panels. That will also be, the specs will also be on the panels. Sometimes it's better to look on your panels. There's also a way to test it, but yeah, VOC is different than the normal VDC. So first you got to put up your rails, then you're going to do your first string. So if you do your first string, we do the cross connection here. So we want to get all the MC4 connectors into one spot. So skip one and then you go to the fourth one and then you come back again. So on a string and the cross connection, even of a normal connection, you will see that your volts will increase. So this is 50 and then it is 101 and then you get to 152 and then you get to 203. That's actually VOC, and your amps will be the same. That is in a series connection, but these panels need to go into a parallel connection now because of his inverter or his MPPT. So there's a few ways to do that, and then it needs to go into the PV combiner box. So in the PV combiner box, we've got a few things. Depends on where you stay, in what country, what your regulations are. But here in South Africa, our PV boxes, combiner boxes look more or less like this. So you will have your 2 fuse holders. They normally, I think it's 32 amps each. And then you get your SPD, your surge protection device. And then again, for the negatives, you get 2, also the fuse holders. And then you got a non-polarity DC breaker. Some people also use isolator switches there, and then you've got your earth connector. So yeah, it's very important to look at the non-polarity. Look at my other videos. There's too much polarity breakers. They are very unsafe if you don't know exactly how the flow of the current is. And yeah, okay, then we've got to go and we got to get all these wires in. So the first string coming in, on the first string will be 203 VOC and 14.47 from each string, and then we've got to go up. So here on the cross connection, you'll see we've got both in the middle so that we can go nicely up into the PV combiner box. These are the earth clamps. There are different types. I like those that clamp onto the panels with a stainless steel little plate that goes through the aluminium, and then also clamps with a stainless steel onto that. So you'll see here you got to go up into your PV combiner box with your earth wire, and that will go into your SPD. That link in the middle is not really there. It needs to go basically, but there's still less space to do all the drawings. But yeah, you got to bond it and then also put an earth spike at that. So some people will also put the earth spike next to the panels where they come off into the ground. Very important to do your earthing for safety reasons. All right, so then we've got to get all these wires up. So on the left-hand side, we'll do the 2 positives, and then on the right-hand side of the SPD, we'll do the 2 negatives. So you see all the wires are nice and neatly up, and then we've got to go and parallel them at the top there. So here you've got a few ways to do it. Use the right cable or bus bars. So the first 2 on the left hand side will go, the positives will go into the SPD, and that will go then back to your MCB, and then the negatives go basically also the same. Loop them together to the SPD and into your MCB, your non-polarity circuit breaker. Very important, and that will give an output when you parallel them 203 volts VOC and 28.9 amps on the output. So according to that, you're going to see what cable you must use and everything, and what fuses you must use. So yeah, let's quickly have a look at that. Okay, so there's your fuses. Let's work it out. Because it's outdoors, we've got to add the times the amps with 1.56, so that will get you to 22.57 amps. Therefore, you will use DC fuse, very important, a DC fuse close to that, which is 25 amps. And then the parallel, you're going to add, parallel, the volt stays the same, but it adds up, so it's 28.94 amps it's going to go out, and times it with 1.56, you'll get to 45.15. So therefore you have to see that you search for something similar. The closest one more or less will be 50 amps. And then also your 10 gauge cable, 6mm, will go to your solar panels if it's anything between 30 and 50 meters. And then your grounding cable will be also 10 gauge, 6mm. I always say don't be shy on your panels on putting decent cable on there, bare copper. Because you never know if you're going to expand later on, then you've got to replace that cable and then you've got to pay again. So copper is expensive. So I would at least maybe put a 10mm there. If I can, I put the 16mm. You cannot go too big with the grounding cable. Okay, just to sum it up, on your two strings coming in, 203 volts, 114 amps from the one string to the other. You get all the cables in the middle. You take them up, and then you come back down with 203 VDC and 28.9 amps. And yeah, hope it helped. If there's something that I missed, please remind me, and we will look forward to something else. Ask questions if you want. I would love to help if I can.